Okay, today we're talking about lesson 3.2, percent increase and decrease. Our essential question is, how do you use percents to describe change? Before we get into this lesson, there are some basic things you need to know about converting a percent to a decimal and a decimal to a percent that we need to go over. So before we even start these, up here I want you to know what a percent means. So a percent, please write this down, is any number out of 100. Okay, so anytime you're talking about a percent, it's always out of 100. When we are trying to convert from a percent to a decimal, we are really dividing by 100. For example, let's say that I have 4% and I want to change my percent to a decimal. Well, what does 4% mean? It means 4 out of 100. Remember that out of, that's our fraction bar, means division. So 4 divided by 100, okay, if I write this decimal 4/100ths, 4 divided by 100 is 0.04. So to go from a percent to a decimal, I just put it over 100, and by division, my decimal is 0.04. It says 4/100ths. Another example would be, let's say I have 52%, and I put 52 over 100. Well, 52/100ths, how would I write that as a decimal? Would be 0.52, 52/100ths. When we're going the other way, when I'm trying to go from a decimal to a percent, let's say, for example, I have 5/10ths. Well, I say that decimal 5/10ths. I would write 5 out of 10, 5/10ths. I want to make it into a percent, and we just talked about a percent being any number out of 100, so I would set it equal to 100 on the bottom, and I'm looking for what percent would go on top. Well, to find my x, what did I do to 10 to get 100? I would multiply by 10. So whatever I do to the bottom, I do to the top, and 5 times 10 would be 50 out of 100. Well, a percent is any number out of 100, so that's my percent, 50%. So 0.5, you know, is the same as half, and half is the same as 50%. All of those are equivalent. We do have a shortcut. Instead of having to divide by 100 or multiply to get 100 every time, we just let you move the decimal. You just have to remember which direction to move it. So we like to talk about Dr. Pepper. And this is just so that you can remember which direction to move the decimal. If you're going from a percent to a decimal, you are going to move in the direction 2 places to the left. So I want you guys to look at that. From a percent to a decimal would be this example right here. From a percent to a decimal, well, the decimal is at the back of the 4. If I move it 1, 2 to the left, I would have a blank space. And what would I fill in my blank space? I would fill it with a 0, and that's how I come up with my 0.04%. When you're going from a decimal to a percent, you're going from the doctor to the pepper, you go twice to the right. So right here, when I'm going from a decimal to a percent, I move it 1, 2 to the right. I would have a blank space, and I would have to fill it with a 0, and that would give me my 50%. You do not have to use this shortcut. You can always do the work that we've shown here to go from a percent to a decimal or a decimal to a percent. It's entirely up to you. But you do need that skill to move on with this lesson. Okay, we're going to go ahead and start. Percents can be used to describe how an amount changes. The change may be an increase or decrease. I need you to write in here percent increase. Describes how much a quantity increases in comparison to the original amount. So you're talking about the percent change, and it's always the amount of change over the original amount. In example 1, okay, we're talking about a percent increase. The problem says, Amber got a raise and her hourly wage increased from $8 to $9.50. What is the percent increase? Okay, so the fact that she got a raise already tells us that that was an increase, but her pay went from $8 to $9.50. We're looking for what percent did they increase her pay by? So we're going to, with this workspace, we're going to go ahead and start with your greater value and subtract your lesser value. That's the first thing you want to do. So our greater value is $9.50. We're going to subtract our lesser value of $8. So $9.50 minus $8. And all of that goes over the original amount. Well, her original amount of pay was $8. So that goes on bottom. Okay, well, $9.50 minus $8. If I go set that subtraction up, you have to... Okay, sorry about that. We were having some technical difficulties. So $9.50 minus $8, I was about to say that you need to make sure you line up that decimal. And when you subtract, you end up with $1.50. So $1.50 over the original amount. Remember, our fraction bar means division. So in order to get our percent, we're going to have to go divide $1.50 divided by 8. You bring that decimal straight up when you're dividing by a whole number, and you forget about it, and you divide as if you were dividing whole numbers. So 8 goes into 15 once. When you subtract, you're going to get a 7. Bring that 0 down. You keep dividing. 8 goes into 78 times, which is 64. Subtract, you're going to get a 6. Attach a 0. Bring it down. 8 goes into 60 7 times, which is 56. Subtract, you're going to get a 4. Attach a 0. Take it down. 8 goes into 40 5 times. You get a 0 remainder. So we are finished. Well, notice that the answer we have is 0.1875. Well, that's a decimal. I don't want a decimal. I want a percent. I'm trying to find the percent increase. So to go from a decimal to a percent, taking that shortcut, instead of having to multiply, I know that my decimal is just going to move twice to the right because really you're multiplying by 100. So 18.75, you want to round it to the nearest percent, which would be the ones place. Looking at the 7, 5 or more, raise the score. This would be 19% increase. That would be my final answer. Okay. On the reflection, it's asking, what does a 100% increase mean? If it was 100%, I want you to write that the amount of change is equal to the original amount. So if it was a 100% increase, basically the value doubles. All right, and now it's going to be your turn to show me exactly what we did up here. Okay, remember this is going to be the formula you're using. Okay, you're going to take your greater value minus your lesser value, put it over the original, and show all your work. So you are doing number 2. You're going to pause your video. Be sure you pause it. Okay, and now we check your work to make sure you're understanding this. Our question says the price of a pair of shoes increases from $52 to $64. What is the percent increase to the nearest percent? So a pair of shoes increases from $52 to $64, and we're looking for a percent increase, and they want us to round to the nearest percent. So if we're using our formula from up above, we take our greater value, 64, and we subtract our lesser value, 52, and we put it over our original value of the shoes, which was $52. When I go subtract 64 minus 52, I get $12. I put that over the original amount of $52. And to find the percent, I'm going to have to divide. So 12 needs to be divided by 52. Well, 52 can't go into 12. That's where our decimal comes in. Bring it straight up, attach a 0, and then divide as if you were dividing whole numbers. So 52 goes into 120 twice, which is 104. When you subtract, you get 16. You attach a 0, take it down, keep dividing. 52 goes into 160 3 times, which happens to be 156. When you subtract, you get a 4. You attach a 0, you take it down. Well, 52 cannot go into 40. You have to go ahead and show that up there with a 0. And when you subtract, that 40 is still there, but you go ahead and attach a 0, bring it down. And now you're dividing into 400. Well, that's going to go about 7 times. And actually, you can go ahead and stop right here, because if I have, if I move it twice to the right to get my decimal, that's going to be 23.07, and they asked me to round to the nearest percent. So I'm rounding the ones place. Looking at that 0, that ones place, remember 4 or less, let it rest, it's going to stay the same, and that's just going to be 23%. That is my percent increase. All right, at the bottom here, it starts to talk about percent decrease, which, by the way, is another vocabulary word in your notes for you to study. It says, when the change in the amount decreases, you can use a similar approach to find percent decrease. I want you all to write in percent decrease. Describes how much a quantity decreases in comparison to the original amount. So we were talking about increasing. Now we're talking about decreasing. We're going to look at some examples here. Okay, so in example number 2, it says, David moved from a house that is 89 miles away from his workplace to a house that is 51 miles away from his workplace. What is the percent decrease in the distance from his house to his workplace? Okay, so he was in a house that was 89 miles away. He moved to a house that is now 51 miles away, and they want to know the percent decrease in distance. So we use the same steps that we took before. We're going to take the greater value and subtract the lesser value. So that's 89 miles minus 51 over the original, which was 89. So 89 minus 51 gives us 38 miles over the original amount, which was 89 miles away. In order to get our percent decrease, we're going to have to go divide, because remember our fraction bar says divided by. So I go divide 38 is going to be divided by 89. Well, 89 can't go into 38. That's when you bring a decimal, bring it straight up, attach a 0. And 89 goes into 380 4 times, which is 356. When you subtract, you're going to get 24. You're going to add a 0, take it down. 89 goes into 240 twice, which is 178. When you subtract, you're going to get 62. Add a 0, take it down. 89 goes into 620 6 times, which happens to be 534. You can pretty much stop right there, because again, when you have your decimal and you move it 1, 2 to the right to get your percent, you're going to get 42.6 as a percent, but they want you to round it to the nearest percent. It says right here, nearest percent. So that's the whole number. Look at those 6. And you're going to 5 or more raise the score. You're going to get a final answer of 43% increase. All right, you're looking at your turn, and you're going to do 4 and 5 the same exact way that we did example 2. So pause your video. Okay, and now we're back to check your answers. Number 4 says, the number of students in a chess club decreased from 18 to 12. What is the percent decrease? Round to the nearest percent. So from 18 to 12, you take your greater value, subtract your lesser, over your original amount of students, which was 18. Well, 18 minus 12 is 6 over 18. Well, notice that would be a fraction already. If I go simplify this fraction, that's 1/3. This is a benchmark fraction you should recognize to be 0.3 repeating as a decimal. So if I have 0.333 and it keeps going, when I move it twice to become a percent and I round, that's just going to leave me at 33%. If you didn't remember that this was a benchmark fraction we've talked about several times in class, you could go show your division 1 divided by 3. You would still end up with the same amount. Number 5, Officer Brimberry wrote 16 tickets for traffic violations last week, but only 10 tickets this week. What is the percent decrease? Okay, so 16 last week minus 10 this week over the original amount of 16 is going to leave you with 6 over 16. When you simplify this, you're going to get 3/8. Well, again, you could go do all this division, but we talked about that shortcut where you know that 8 could go into 1,000 to get your decimal. What do I multiply by? 125. Whatever we do to the bottom, we do to the top. 3 times 125, which is 375 thousandths, which is 0.375. That's our decimal. So to get our percent, we go 1, 2 to the right. That's 37.5%. But when we're rounding to the nearest percent, that's the whole number place. That's going to leave me with 38%. Okay, the last section is talking about using percent of change. Given an original amount and a percent increase or decrease, you can use the percent of change to find the new amount. So in this example number 3, it says, the grizzly bear population in Yellowstone National Park in 1970 was about 270. Over the next 35 years, it increased by about 115%. What was the population in 2005? So it was 270. It increased by 115%, and they want the new population. So you can find a new amount if you know the increase was 115%. So you're trying to find 115% of 270, and you have to remember that of means to multiply. So I'm going to have to multiply. When you're multiplying, you can't multiply by a percent. Even in a calculator, it automatically changes it to a decimal. So we talked about from a percent to a decimal, you go twice to the left, and so really you're going to be multiplying 270 times 1.15. So that would be 0, 35, 13, skip a space, skip 2 spaces, oops. Okay, and there are 2 decimal places in my problem total. So remember, you start at the back and you go 1, 2. That would be 310.5. Okay, well that would round to 311 grizzly bears. But in order to find your new amount, notice it says here you have to add your amount of change to your original. Well, our original was 270. So you're adding 311 to 270. And so when you go do that, 270 plus 311, you get 581 grizzly bears. And that's our final answer. On the reflection, why will the percent of change always be represented by a positive number? Well, I want you to write that is because it's equal to the greater value minus the lesser value, which is always positive. Okay, it's going to be your turn again. I need you guys to pause your video and go ahead and try numbers 8 and 9. Okay, it says a TV has an original price of $4.99. The new price after the given percent of change. So they want you to find out, what if there was a 10% increase on this television? Well, that means you would have to find 10% of $4.99. Again, of means to multiply. You have to change this back to a decimal twice to the left. So you are going to be multiplying $4.99 times 0.10. And when you add that up and you put your decimal back in, that's $49.90. But again, remember, you have to add that to your original. So $4.99 plus $49.90, don't forget to line up your decimals, is going to leave you with $548.90. And on number 9, they want a 30% decrease, so you're going to have to find out what is 30% of $4.99. Again, make that your decimal. $4.99 times 0.30. Okay, that's $149.70, but again, you're going to have to go back to your original, and since it's a decrease, instead of adding them, you're going to be subtracting your original amount of the TV minus the decrease. Let's say there was a sale, to see what your new cost would be. You're going to have to regroup here, regroup again. And your new cost should have ended up being $349.30. All right, we are going to do more examples in class, and if you have any questions or there was something I went over that you're still unsure about, please write them in the margin. Remember to ask tomorrow in class, and we will see you then.